Hi everyone, my name is Amer Avdagic and I'm a senior engineer with the product development team of Sharona Dental Systems Incorporated. I'm here with you, the folks of Saltzman Dental Group, today to discuss the possibility of replacing the current phosphor plate films that you use for dental radiographs with the new and improved Schick digital intraoral sensors. I'd like to start today by going over the agenda and then moving into some detail from there. We'll start today's discussion by discussing the phosphor plate films and the negative aspects of their use. Those negative aspects are going to include increased patient exposure to radiation, decreased image quality, prolonged film development, and loss in revenue. From there, we'll discuss the solution to those issues, the digital intraoral sensors. We'll discuss how they're used, their benefits, and what makes them the standard of care today. From there, we'll move on to the project budget. So we'll break down what it's going to cost you to not only purchase the equipment necessary to use the system, but we'll discuss the cost of training your employees so that you're fully aware of what it'll cost you to invest in this great opportunity. Once we're done with the budget, I'll go over a brief conclusion and then I'll answer any questions that you may have for me. So with increased patient radiation exposure, I'd like you to remember two things as I share some statistics with you. The first is to know that it takes roughly 20 images or radiographs being exposed on phosphor plate films to equal the amount of radiation that an individual would experience while being outside in the sun all day. Now, keeping that in mind, it should also be known that all dental professionals, as it is the standard of care, recommend that all patients have 4 bite weighing x-rays done annually and then a complete mouth series taken every 3 to 5 years, which consists of 20 films. On average, that turns out to be roughly 8 or 9 films annually over someone's lifespan who sees the dentist or hygienist on a regular basis. Now, with that in mind, I'd like to just read a statistic to you that was presented to the Vermont Technical College's dental hygiene students by Tom Kellogg, an Associate Radiation Safety Officer from the University of Vermont. Mr. Kellogg stated that the conventional phosphor plate film produces 0.7 millirems of radiation per film, while the digital intraoral sensor produces 0.35 millirems of radiation per film. Now, these numbers may seem insignificant when comparing how much radiation it takes and how many films it takes to match the radiation of someone being outside all day in the sun. But the thing to keep in mind is that today many patients are seeing the dentist on a regular basis from early childhood until they're elderly. So with that being said, that's many years of radiation exposure. Now, although studies don't suggest or prove that dental radiographs cause cancer or damage to skin, it is very well known that radiation itself causes cancer or has the potential to cause cancer or defects to the skin or bodily systems. So because dental radiographs do produce radiation, the thing to keep in mind is radiation regardless of what it comes from. So if the opportunity is there to decrease the radiation that a patient is being exposed to, it should always be taken because the patient is the one that matters. As for decreased image quality of phosphor plate films, that's also crucial because proper diagnosis is the most important aspect from the clinician's point of view or position. The clinician needs to be able to view images and be confident in what they're seeing and diagnosing. In a study done and published in the International Journal of Health Sciences, the study concluded that raters who happen to be dentists made more errors in identifying structures of interest in dental radiographs when they viewed phosphor plate films versus digital intraoral sensors. So this study supports that dentists have a harder time properly and accurately diagnosing conditions using phosphor plate films versus digital intraoral sensors. And I attribute this to the fact that phosphor plate films cannot be altered once they're developed. The color contrast cannot be changed, the size cannot be changed, the clinician or whoever is viewing the image cannot zoom in on specific areas to get a better view. It's simply the image is what it is. With digital intraoral sensors, the image is displayed on the computer monitor, and the color contrast can be changed, which allows for caries to be viewed more easily and other structures as well. The clinician can zoom in on specific areas that they would like to see a little bit better. So there are many alterations and tools that can be used on the digital intraoral sensor image to allow for more accurate diagnoses that are not available on phosphor plate films. So in the end, the decreased image quality of phosphor plate films is really taken away from proper diagnosis, which is taking away from patient quality care. Now, for prolonged film development, an article also published in the International Journal of Health Sciences stated that processing a single phosphor plate film takes roughly 5 minutes on average. Most processors can process 4 or 5 films at a time. So when a patient is having a complete mouse series done, that adds up to about 20 minutes just in processing time. Those 20 minutes could be spent doing many other things with the patient, like providing prophylaxis or personal oral hygiene instruction or cancer screenings, many other things that benefit the patient. They'll benefit the practice in terms of revenue. It's just so much more efficient if you can save that time. And with the use of digital intraoral sensors, you can save that time because the image is transferred directly from the sensor that's in the patient's mouth to a little converter that's in the middle of 2 cables, and then that converter sends the image over to the computer, and it can be viewed within 3 seconds of being exposed, within 3 seconds of the film being exposed. So that time, that crucial time that can be saved is being saved by digital intraoral sensors. As for loss in revenue, phosphor plate films cause a loss in revenue in 2 aspects. One, as I just discussed, they take a while to develop, and with that time that the clinician is using developing films, they're losing revenue by not providing treatment for the patient. A second way that phosphor plate films cause a loss in revenue is simply that they cannot be reused. Phosphor plate films can be exposed once, and then the image is there permanently, and that's it. Therefore, phosphor plate films must be purchased over and over and replaced after every single use. And although the initial cost may be cheap per film, in the long run, the cost for phosphor plate films is going to exceed what it costs to actually purchase the digital sensors, which are constantly reused and don't need to be replaced for quite some time. Now, discussing the digital intraoral sensors, as we already covered, they're going to decrease the patient radiation exposure from 0.7 millirems of radiation that comes from phosphor plate films down to 0.35 millirems of radiation per digital intraoral sensor film. It's going to provide the clinician with increased image quality, which is going to help with the diagnoses, which is great. And it's also going to help with explaining certain things to patients, because you will have those patients that are interested and care to know what you're looking at and how you're going to diagnose them and the condition of their mouth and their oral health. The image is instantly viewable, which helps both production, as mentioned earlier, in terms of saving time, but it also is going to make things easier by storing images in computers, so you're taking away the physical aspect of having to store physical film in cabinets or files or whatever it may be. And finally, the increased revenue is really important, more for the clinician than the patient. The patient is going to pay the same price on average for a phosphor plate film that they will for a digital intraoral film. However, with the time being saved, the clinician can provide more radiographs for more patients in the same amount of time that they do with phosphor plate films. So in the end, the revenue is increased through an increase in production. And also, the digital intraoral sensors, like I said, only have to be purchased one time. So this image here is the digital intraoral sensor. It's simply a block that's going to be placed in the patient's mouth and held by a plastic XCP device. Now, obtaining the image is very simple. It's going to be done the same way that a phosphor plate film is obtained. The sensor is going to be covered with a thin plastic barrier. The plastic XCP device is going to be placed on it, and the patient's going to bite on that device. Once the patient bites, the camera or the X-ray tube head is positioned as needed, just like a phosphor plate film, and the sensor is exposed. Now, once it is exposed, within 3 seconds, the image is going to show up on the computer screen. So moving on to the budget and what it's going to cost your practice to obtain this technology and take full advantage. Each intraoral sensor is about $5,000, and you need to have a size 1 and a size 2 because you need to treat different size mouths, and size 1 is typically used for anterior teeth and size 2 is used for posterior teeth. Now, since each film is $2,000, that's going to run you about $10,000 for the 2 size films. And if you're interested, there's a 2-year insurance plan for the sensors that's about $2,000. That's completely up to the clinician based on how comfortable they feel handling the film and purchasing it, without the plan or not. While the staff is being trained, they're going to have to be paid. We estimate that payment at about $5,000 to cover all the staff members. That may be subject to increase or decrease depending on the size of your practice. And finally, there's a cost of the trainer. The trainer is going to be the one to not only show your clinicians how to use the sensors, but they're going to train them and provide information on how they work and why they're better than phosphor plate films, so that when patients are asking questions, they're fully confident and can rely on your hygienists and dentists so that they know that what they're having done to them is the standard of care and what they should be receiving in the dental office. So grand total, that comes out to about $19,000 to implement this system. So the conclusion is that digital intraoral sensors are going to provide less radiation exposure to the patient, which is arguably the most important benefit. It's going to increase image quality, which is going to help diagnostics, also very important to consider. The image is going to be instantly viewable, and there's going to be an increase in revenue. With an increase in revenue, the practice is doing better. It's going to be able to function and keep functioning for a long time, because without revenue, there is no business and no practice. So is there any questions? Okay, thank you very much, and I hope to hear from you soon.